In this video, we're going to talk about using conditional probability in disease diagnosis questions. So this is one important application of conditional probabilities. So one important application of conditional probabilities is in tests to determine whether a person has a disease. So sometimes a test will say that, oh, you have the disease. Sometimes a test will say you don't have the disease. And tests aren't necessarily perfect. Sometimes they're right, sometimes they're wrong. So I want to introduce a little bit of terminology that gets used in medicine to indicate what a test will tell you. So this definition says that a medical test being positive indicates that it thinks you have a given disease. It doesn't necessarily mean that it's right, so maybe you do have the disease, maybe you don't, but the fact that the test shows up positive indicates the test thinks you have that disease. All right, so similarly, a test being negative indicates that it thinks you don't have the disease. And hopefully the test is right. If it's a good test, it'll be right most of the time. So when it is negative, hopefully you don't actually have the disease most of the time. But it could be wrong. Sometimes a test will be negative, although you might actually have the disease. That can happen. Alrighty, so let's look at an example. Alrighty, so I have this Harry Potter example, which says that the wizarding community has a new test for the disease Spattergroit. It's estimated 15% of the community has it. For those who have Spattergroit, it correctly says they do 96% of the time. For those without the disease, it incorrectly says that they have Spattergroit 8% of the time. A randomly selected patient obtains a negative test result. What is the probability that they actually have the disease? Round to 3 decimal places. Okay, so let's begin by labeling some of these outcomes. So there's a matter of do they have the disease or not. So I'm going to let S be the event that this person has Spattergroit. And I'm going to let D be the event that they don't have it, or this person doesn't have it. I could have also called that S complement if I wanted to, but sometimes I just like to write a different letter altogether. So I just want to show you that we can do that. And this is something that we've seen before as well. And there's also the next stage about, does the test indicate that it's positive or does the test come up negative? So I'm going to let P be the event that the test shows up positive, and N is going to be the event that the test indicates that it is negative. Okay, so with that in mind, we are trying to find the probability that this person has the disease. So this person has Spattergroit. But we're given something, because in the previous sentence it says that this randomly selected patient obtains a negative test result. So given that they have a negative test result. So the negative test result means this test thinks that they don't have the disease. So we are trying to find the probability that they actually do have the disease, even though the test says that they don't. In other words, we're trying to find the probability that the test was wrong here. Okay, so the probability using my letters has Spattergroit is S and negative is N. So we want the probability of S given that N occurs. All right, so I'm going to zoom out a little bit so I can still look at some of these numbers while forming a tree diagram. Okay, so let's write where we begin. And a tree diagram might be helpful because we have these stages. There's this matter of, do they actually have the disease? And then what does the test indicate? Then we can form the outcome. And then finally write a probability for each outcome. So for the disease, either they have spattergroit, which is S, or they don't, which is D. And then from there, from each of those, either it gives a positive test result or a negative one. So even from D, I draw an arrow to P or to N. So now my outcomes are S, P, S, N, D, P, and then D, N. So let's write down some probabilities. In the question, it says that 15% of the community has the disease. So we're going to write a 0.15 going to S. And that means that going to D is 0.85, because those two numbers got to add up to 1. Let's see what it says next. It says, for those who have spattergroit, it correctly says that they do 96% of the time. In other words, starting at the branch for S, if they have spattergroit, it will say that they do, which means a positive test result, 96% of the time. 96% of the time. And then in the next sentence, it says, for those without the disease, which means starting from the branch at D, those without the disease, it incorrectly says that they have spattergroit 8% of the time. So given that they have the disease, when it says that they have spattergroit, that means, again, it's talking about a positive test result. Positive test result is when the test says you have the disease. And the percentage is 8%. So as a decimal, that is 0.08. Okay. So really pause the video if you're have questions about, wait, why is this going to P and not to N? That's really important for this question. So now these missing probabilities will be 0.04 here and 0.92 here. So to get my probabilities, I multiply, and I'll get 0.15 times 0.96. And then down here, 0.15 times 0.04. And then 0.85 times 0.08. And then finally 0.85 times 0.92. Now let's zoom it back in a little bit now that I got those numbers. All right, so this first one is going to be 0.144. Then we have 0.006. Then it's 0.068. The last one is by far the biggest, 0.782. So now we are ready to write down the probability of S given that N occurs. So using our formula for conditional probability, it's the probability of S intersected with N on top, the probability of N on the bottom. Okay, so let's find the probability of the intersection of S and N first. So here's the outcome where S and N occur. Here's the probability. So we are going to write that on the numerator, 0.006. And on the denominator, I need the probability that N occurs. And N occurs in two outcomes. Here, negative test result, and here. So let's highlight these numbers. I'm going to use these ones on the denominator. We'll have 0.006 plus 0.782. All right, so if we round this to 3 decimal places, we will end up with 0.008 for our probability. And just to give a reference, if I think about this as a percentage, I would multiply this by 100, which would move the decimal to the right 2 places. So as a percentage, this is 0.8%. And that is super small. And that's good for this question, just thinking about what it's asking, because this is asking, like, when we have a randomly selected patient who has a negative test result, meaning the test thinks they don't have the disease, we were looking for, well, what's the probability that the test got it wrong and they actually did have the disease? Well, the probability is really low. It's less than 1% of the time it makes this type of mistake.